So heat treatment of the muscular paints involve the radiation of the wavelength of 900 nanometers. Which spectral line of the hydrogen atom is suitable for this? This is the question related to the atomic structure. So we know that 1 by lambda is equal to RH into 1 by N1 square minus 1 by N2 square. This is a Rydberg's formula. So here it is, Pascal series is given. For Pascal series, N1 value is also given. N1 is equal to 3 and N2 is equal to infinite. Then 1 by lambda is equal to RH into 1 by N1 square is 9. 1 by N2 square can be taken as 0. 1 by infinite square 0. 1 by lambda is equal to RH by 9. Then lambda is equal to 9 by RH. So 9 by RH. 1 by RH value can be taken as 912 angstroms. So 9 into 912. So if I am going to take 9 into 912, so here it is 9 into 912. That will be nearly equal to 900 into 10 to the power of minus 9 meters. That will be equal to 900 nanometers. Option 1 is the correct answer for the given question. CrCl3xNH3 can exist as a complex. 0.1 molar aqueous solution of this complex shows a depression in freezing point as 0.558. Assuming 100% ionization of this complex, coordination number of chromium is 6, the complex will be. This is a question related to both coordination chemistry and diluted solutions colliative property concept. We know that depression in freezing point delta Df is equal to Kf into small m. And the delta Df value is given as 0.558. Kf value of water is 1.86 into the molality of the solution is 0.1 and you have to introduce the factor called as I factor. Now I factor is equal to 0.558 by 0.186, that will be equal to 3. So 100% ionization takes place means it is a strong electrolyte. The compound which can give 3 ions is the answer for this question. For example, CrNH3 5 times ClCl2 on ionization produces CrNH3 5 times Cl and 2 Cl minus ions. So total 3 ions are produced. Which is the correct answer for this question? Here 4 ions are there, here 2 ions are there, here 0 ions are produced. Option 3 is the correct answer for the given question. FeO4 2 minus gives rise to Fe3 plus with an electrode potential of 2 volts. Fe3 plus will give 0.8 volts to give Fe2 plus. Fe2 plus becomes Fe by minus 0.5 volts. In the above diagram, the standard electrode potentials in the volts are given. I have to find the value FeO4 2 minus 2 Fe2 plus. So for that one, what I have to do means, so take FeO4 2 minus, FeO4 2 minus, that have been changed to Fe3 plus. The oxidation state of Fe in FeO4 2 minus is plus 6 and Fe3 plus 3. So change in oxidation state is 3. We know that delta G is equal to minus NFE naught. Minus 3 into F into E naught value is 2 here. And the second one, Fe3 plus has been changed to Fe2 plus. Delta G naught 2 is equal to, here 3 and 2, only one electron is changed, minus 1 F into 0.8. If you are going to add this one, here this and this will be cancelled, then FeO4 2 minus will give rise that Fe2 plus. Here it will be plus 6 oxidation state, here it will be plus 2 oxidation state. Then delta G3 is equal to, difference is minus 4 into E. That E naught you have to find here. So Gibbs free energy is an extensive property, additive property. That's why delta G3 is equal to delta G2 plus delta G1 minus 3F into 2 minus 1F into 0.8 is equal to minus 4F into E naught. F will be cancelled. So 3 2s are 6F plus 0.8F is equal to 4F E naught. F will be cancelled. 6.8 by 4 is equal to E naught. So the final answer for this question is 1.7 volts. It is there in option 1, which is the correct answer for the given question. 2.8 into 10 to the power of minus 3 mole of CO2 is left after removing 10 power 21 molecules from xmg of the sample. The mass of the CO2 taken initially is. So, initial number of molecules, initial number of CO2 you have to take, that will be equal to x into 10 to the power of minus 3 by 44, because initially you are going to take xmg. Now, how much left? 2.8 into 10 to the power of minus 3 is left after removing 10 to the power of 21 molecules. So, number of moles of CO2 removed is equal to 10 power 21 by 44. Given number of molecules by Avogadro number you have to do here. Avogadro number. So that Avogadro number is 6.023 into 10 to the power of 23. So the total moles initially taken is x into 10 to the power of minus 3 by 44. Removed moles are 10 to the power of 21 by 6.023 into 10 to the power of 23. Still left are 2.8 into 10 to the power of minus 3. If you are going to solve this question, then you can get the value of x as 196.2 into 10 to the power of minus 3. That can be taken as 196 milligrams. That is there on option 1, which is the correct answer for the given question. Ice is at minus 5 degrees centigrade, is heated, becomes the vapor with the temperature of 110 degrees centigrade at atmospheric pressure. The entropy change associated with this process is. So initially you are going to take the ice at minus 5 degrees centigrade, which gives rise that ice at 0 degrees centigrade. That is can be taken as the delta H1 value, that heat required to change the ice to into its this particular ice at 0 degrees centigrade, and entropy change is delta S1. And now ice exists at the equilibrium with the water at 0 degrees centigrade only. So water is also there at 0 degrees centigrade, both will be at the equilibrium, whose entropy change delta S2. Now water has been changed to 100 degrees centigrade, whose entropy change is delta S3. At 100 degrees centigrade, there exists an equilibrium with water vapor. The temperature remains same at 100 degrees centigrade. Now the water vapor has been changed to water vapor, but the temperature has been changed to 110 degrees centigrade. So the entropy change associated with the first step is delta S1, second step delta S2, third step delta S3, and here it will be delta S4, and here it will be delta S5. So the total change is delta S, that is the sum of delta S1 plus delta S2 plus delta S3 plus, delta S4 plus, delta S5. So for the first one, there is no equilibrium establishment, there is no phase change also. But this process takes place at the constant pressure, at 1 atmospheric pressure. Then the formula how to associate it is delta S1 is equal to NCP delta T. So if I am going to do the integration for this one from minus 5 degrees centigrade, that is 268 kelvins to 273 kelvins. So from 268 kelvins to 273 kelvins, Cp by T at delta T. So this is the value of delta S1. And second one is the phase transfer. For phase transfer reactions, we know that delta S is equal to delta H by T. So for delta H, value can be taken for the transfer of ice at 0 degree centigrade to water at 0 degree centigrade. That is delta H fusion by temperature. And now water has been changed to water at 100 degree centigrade, water vapor at 100 degree centigrade. Then that will be equal to the value of delta S3 is from 273 to 373 Cp by dt at T. And now again equilibrium establishment takes place, that is delta H vaporization by T, because water has been changed to water vapor at 100 degree centigrade. And later this 100 degree centigrade has been changed to 110 degree centigrade. Again we have to use the formula NCP delta T. So the formula is 373 kelvins, 100 degree centigrade to 383. You have to do the integration. So option 2 is the correct answer for the given question. Which of the following happens when ammonium hydroxide is added gradually to the solution containing 1 molar A2 plus and 1 molar 3 plus, and KSP of AOH twice is 9 into 10 to the power of minus 10, and KSP of barium hydroxide is 27 into 10 to the power of minus 18. We know that whenever the ionic product value exceeds the solubility product, then only precipitation takes place. So for example, if I am going to take AOH twice, which is an equilibrium with A2 plus and 2OH minus, KSP is equal to concentration of A2 plus into OH minus whole square, not KSP. You are going to calculate ionic product, both are having the same expression. So let us consider the KSP value for the AOH twice is 9 into 10 to the power of minus 10. That will be equal to A2 plus concentration can be taken as 1 molar, and I have to find the OH minus concentration. So OH minus concentration need to precipitate that AOH twice is 3 into 10 to the power of minus 5 mole per liter. In similar way, you have to find for BOH thrice is also, which has been dissociated as B3 plus and 3OH minus ions. So 27 into 10 to the power of minus 18 is equal to concentration of B3 plus is 1 and concentration of OH minus whole cube. So cube root of 27 is 3 into 10 to the power of minus 6 is equal to the concentration of OH minus. That means to precipitate barium hydroxide BOH thrice, we need 3 into 10 to the power of minus 6 molar. To precipitate AOH twice, we need 3 into 10 to the power of minus 5, OH minus concentration. So 3 into 10 to the power of minus 6 is low when compared to 3 into 10 to the power of minus 5. That's why BOH thrice will precipitate it before AOH twice. Option 1 is the correct answer for the given question.